A very good evening and welcome to our student webinar series. These webinars are dedicated to the students across all the institutions in South Africa. The webinars are run by the SAICE SOS as well as the SAICE Academy to allow the students to engage with the industry. Today's webinar, or today's installment of the webinars, is about the Mandlakazi Regional Water Supply Scheme. This is actually part of the priority projects that were identified for unlocking socio-economic development in South Africa. The presentation is given by the team at MSW Consulting. So for today, we have three presenters, and as a way of introduction, we have Mr. Justin G. Hemming, who is experienced in planning, road design, water, bulk and reticulation design, contract management, and hydraulic analysis. We also have Ms. Faith Tambwali, who is experienced in design of rural water reticulation systems, hydraulic modeling, steady-state analysis, design of bulk earthworks, reservoir platforms, and design of roadworks and parking. We also have Thulasizwe Ngcobo, who is the Associate Director. He has various experience in design, construction, and administration of various civil engineering projects. Before we begin, and as always, we'd like to give a few housekeeping notes. Obviously, you would want to have a webinar without any disturbances. So if the delegates can please ensure that their mics and videos are off. If there are any questions, we do have a chat section in this platform. So please post there and it will be read towards the end of the presentation. I believe that's all. If you are ready, Justin, I think you can share your presentation and start.
Just need to unmute Justin. There we go.
All right. Hi. Good evening, everyone. Thank you so much for this opportunity. Thanks, Karaba, for the introductions. I'd also just like to thank our client, Zululand District Municipality, for, without them, we wouldn't be reporting on this project. It's going to be, sorry, firstly, can you hear me and can you guys see the picture okay?
Yes, can hear perfectly, can see the picture.
Great, thank you. Yeah, look, firstly, it's difficult to try and condense 10 years into probably what's going to be a 45-minute session, so we may be speaking fast. Look, this particular project it's nothing specific that stands out about it other than possibly the size. It is a fairly typical rural regional water supply scheme. I think the nice thing to present on is really it's a holistic project in that, obviously we're taking it from inception through to close out, so all stages of the project life cycle are covered. And with any water project, there's a lot of aspects of engineering. It's not just civils. There's process, there's mechanical, electrical, and the structural and the like. So it does cover a broad range. And yeah, thank you so much for the opportunity. There we go. Okay, so just briefly, thanks, you did introduce us, so I don't need to go into too much more detail there. I'll just be covering the first two aspects of the presentation, which is really introduction, planning studies and overview. A brief look at some of the design aspects of the abstraction, treatment works and pump station transfer design. Faith will then come in and cover detailed design of bulk pipelines and domestic reticulation. And we'll finish off with Thulasizwe Ngcobo, who will cover the tender implementation and closeout aspects. A little bit of background about myself. I'm not as young as I look in that picture. I made sure I gave you guys a nice looking one. I have approximately 28 years of postgraduate experience in industry, included 7 years in the road sector at the Department of Transport, a year in the UK with a consulting firm, 3 years at UWP Consulting Engineers, and the last 15 as a director at MSW Consulting. Not too many career highlight points there, but if I can just maybe refer to initially age 24, I think being thrown in the deep end to run the roads construction unit at Port Shepstone was a highlight. Then after 12 years of running around on construction sites, I eventually convinced someone to put me in a design office. Thanks Leon Panjeda. And yeah, coming to the realization, I'm definitely not a design engineer, but yet going on to project manage, water supply projects to over 300,000 people, and obviously becoming a director of this firm, which has been fantastic. Just a little bit in terms of the company. MSW Consulting, or Born Sanders and VM, was established in 2006 following a breakaway from the old Sanders and VM CC, which is based in East London. And I think they had a reputation very much in the water sector as well. We've now got a centralized office in Hilton, which includes 6 professionals, approximately 14 unregistered engineers and technologists, although they're very much on their way to getting there, 4 CAD operators, and a small component of really hardworking admin people that keep us on our toes. We are ISO registered, and our main focus is bulk water, water and wastewater treatment, and domestic reticulation. There's just a list of some of the standout projects over the years. We are obviously KZN based, and a lot of our work is municipal and water board, and a lot in KZN. We've also worked in other parts of the country. The Come To Us irrigation scheme in the Eastern Cape stands out. And we've worked as far afield as Nigeria as well. Right, I'm just going to briefly just show you that diagram, which I'm sure you're all very familiar with, the project life cycle. I'm just going to focus on the planning stage. Sorry, just give me 1 second. There we go. So this is just a locality plan of the project area. I'm just going to get the laser pointer here. So Zululand District Municipality is located in the north part of the province. It's the largest of the district municipalities in KZN. And if you look at the project footprint of Mandlakazi, it's on the eastern boundary of Zululand. It borders with Umkanyakudi District Municipality, and it is one of 10 back-to-back regional projects in Zululand. I think they were very forward-thinking in the early days to in those days look at regional schemes, and certainly has been a benefit. Just some numbers in terms of Nongoma LM. So Mandlakazi is within the Nongoma local municipality. It, in 2011 census, was ranked in the bottom 10% in terms of access to potable water and unemployment, and certainly we're about 50% of the way through the implementation of the last of the phases, or the second last of the phases. And yeah, we like to believe that those numbers have vastly improved since then. So just in terms of the exit stages, I'm just going to start with inception. Obviously, at this stage, one is confirming the terms of reference. We went through an open tender process and were awarded the project in 2013, which included all stages of the scope. And initially, just treatment works and what they called phase 5. At this stage, we obviously had to confirm the battery limits, including the project sort of scope of work and the boundaries, project boundaries. We look at this Google Earth image. You can see the blue area here. That is what we call phase 5. It's an area of 650 square kilometers, so you can see it is quite a large area. Prior phases included phase 1 to 4. That's the sort of brown shaded area, and those were completed between 2003 and 2017. And the future phase, in the yellow area down to the south, is Hlabisa LM, Hlabisa local municipality, which actually falls under Umkanyakudi, and it's thus a cross-border scheme. Ultimately, upon completion of the phase 6 project, supplying that whole area, we'd be looking in 30 years' time at about 280,000 people and 45,000 households, with a total potable water demand in the order of 60 megalitres per day. In terms of infrastructure, we'd be looking at about 250 kilometres of bulk mains, up to 1 meter diameter, probably over 1,000 kilometers now of domestic reticulation, and that's just in phase 5, 10,000 yard taps and 30 odd reservoirs with a total capacity of about 30 megalitre storage. Okay, then we get into stage 2, which is the concept and viability stage. And at this point, obviously one needs to review previous inception reports and business plans and feasibility studies and the like. Developing obviously our own feasibility for this particular phase and business plans. One in the process does do quite high level preliminary design, which includes obviously doing the domestic house counts, water demand, hydraulic analysis, reservoir zoning, prelim bulks, routing and sizing, and capital cost estimates for business plan purposes. And obviously applications, key specialist studies at this point in time are critical too. So planning documents required by Water Affairs for this particular project. That's just a list of some of the processes we've had to go through in the planning phase. Updating an original phase 5 technical report back in 2016. At that time, we were looking at about 1.2 billion for the project. That was followed up by an IRS or implementation study just to allow the department, give them satisfaction that they could start releasing the funds. With the recent addition of phase 6 and additional work that's needed to be done upstream of the treatment works to ensure capacity for the long term and to supply Slabisa, we've had to do a new feasibility study, and our latest costing estimates for the whole project are in the order of now 3.2 billion. How things move in a couple of years. We've also been busy with a lot of WSIG, which is applications for reticulation, sort of bite-sized projects. For the domestic reticulation, I think we've completed around about 5 or 6 of those now. In total, I think we've got in the order of 18 reticulation contracts that need to be rolled out. And then geotechnical studies are almost complete. I think just one final phase to complete, as well as a hydrological study that was done for the new abstraction on the Pongola Port or Jazini Dam. In terms of the sort of specialist studies and approvals, obviously ESCOM and DOT wayleaves, those are ongoing. The Ngonyama Trust application was submitted some time back, and PTOs are all signed up by Nkosi. This is obviously all in tribal land or traditional council land. So that process started many years back. The EIA was a basic assessment report, and that was received a couple of years ago and included for phase 5 bulks and the abstraction. That's now being expanded to include for the rest of the phase 6 project as well. That's underway. We've got water use licenses in place in terms of the Jazini abstraction license, as well as the rest of the project. We've also developed a borrow pit, which is not something we often do, but I think with the level of rock and shortages of good quality bedding material, we developed a borrow pit on one of the local rivers, where we have a water use license and DMR permit for backfill or bedding for the pipelines. Just drop the slide in here for reference, really. If one goes back to Ellison Lawless's numbers and needs books of, I think, 2005 and 2007, they were quite damning of the state of municipalities in terms of their ability to implement projects. I think I do like to believe, certainly in KZN and certainly in this particular district municipality, that has changed, and we've seen a vast improvement in terms of the ability to resource and implement projects. But I'd say on the planning side of things, there's still much need for improvement and growth. The mantle very much for planning a project and conceptualization, I believe, is still falling too much on consulting engineers. But obviously we take that and we run with it. And yeah, maybe just as a as a guide to students out there that or young consulting firms that are taking on new work is don't keep your blinkers on, because often the planning documents are limited, and be prepared to do a little bit of work at risk to firm up on planning studies. And that just sort of leads to the next slide, Planning 101. Two sort of key issues I wanted to discuss there, time and future proofing. I think that sort of talks to what I was saying a moment ago. Our initial appointment was for 10 megaliter treatment works, which we were required to design in 3 months. Fortunately, we did work at risk. We did look at some of the planning studies, and we found limitations and work that needed to be done to ensure we were sizing things correctly. And ultimately, a 30 meg works was designed. It was built as a 20, but I'm just making the point. Future proofing, theoretically, when one takes on a project, you believe all the feasibilities and all that sort of planning documents are done and dusted, and you can just run with the design phase. But things are moving quickly. Technology changes. Old studies are possibly antiquated, and there's changes in political mandates, and so one needs to constantly revisit planning documents. Sometimes projects take 10 to 20 years to get off the ground, and so it's really important just to review all of that and ensure that the design life of it is as per the client's philosophy. And then obviously, the feasibility stage of a project should probably also be done to a further degree than one imagines, particularly I believe, with water. You can't really make assumptions on pipe sizing and then expect that to be a feasibility. And then just in terms of costs, obviously, if you do this accurately, your costing for business plans are going to be better, and you're not going to be finding yourself going back to get additional funding at a later stage. I'm short, I think, on time, so I'm going to have to rush through the second aspect of the presentation. Apologies for that. I'm just going to touch on the abstraction, water treatment and pump stations. So up there in the north is Jazini Dam. We looked at 9 different possible abstraction sites and ultimately settled on this one. MSW was involved in the preliminary stages of this, but it's being implemented now by ECA NFM Consulting, and is actually under construction at the moment. The scope of work includes over 60 megaliter abstraction facility with multiple draw-off levels, because that dam mill does fluctuate quite significantly between seasons. It includes 30 kilometers of 1 meter diameter raw water rising mains and pump stations through to the treatment works. That's the red line that you can see there. And it bypasses Mkuzi town, so it also supplies the Mkuzi treatment works. This is being implemented over a 5 to 6 year implementation plan. The treatment works was commenced in 2014. It did take a long time, but ultimately we got there. It's a conventional plant with 2 circular clariflocculators and a rapid gravity filter block. Includes backwash and supernatant recovery. That's just because the abstraction is so far away. We need to ensure efficiency, and we estimate probably waterworks losses of around about 2.5%. We dose with lime, organic polymer, and there is ability to do chloramines to ensure a longer decay time, because the system's so big, but at the moment they're just dosing a regular gas chlorine. And we achieve a final water quality in terms of SANS 241. Upgrade capacity is at the moment is restricted by the bulk, so we've only built it as a 20 meg works for now. But when the new raw water line comes into the system, it'll be able to do 60 meg. So we are in the prelim stages of that design. And then I'm just going to jump into pump station and rising mains designs. Apologies, I do have to rush through this. Very difficult terrain. We've got very steep slopes. We've got sort of grades up to this pump station in excess of 30%. You'll see that I've put lions. One of the pump stations is located in a game reserve, so that was also a reality. And we've had to come up with some quite smart pump solutions on the site, including vertical spindle pumps, where you've got small sites. Eskom phase imbalance is an issue, so using VSDs is a problem. And obviously on the bigger pump stations, we have to look at the surge transient analysis. I had some nice little videos of that, but I really think we've run out of time. I have to move on to our next presenter. But those are just air valve positioning, non-return valves, pressure anticipation and relief valves and flywheels. Those are all mechanisms that we now putting into some of our systems to mitigate against the transients. I think this is the last one. Key rising main design factors. Obviously, pipe cost is just one aspect of selecting a pipe. Velocities are key with the rising main in terms of keeping friction losses down, but material selection and type is also key because it has other aspects and advantages and disadvantages. One needs to look at the modulus of elasticity in terms of transient analysis, restrained versus unrestrained systems, corrosive conditions if you're having to use cathodic protection for steel, and a key element that's possibly not often utilized is doing pipe sizing economics, where you're taking into account the capital and operational costs over the design life to determine your pipe size and material. Thanks very much for that opportunity. I'm going to hand over to my colleague Faith to take you guys through the next presentation. Thank you.
Thank you, Justin. Good evening, ladies and gentlemen. My name is Faith Tambwali. I'm a design technologist at MSW Consulting. I have a Bachelor of Technology in Civil Engineering, specializing in water engineering. My key experiences is in design of rural domestic water reticulation systems, hydraulic modeling, and steady-state analysis of domestic water reticulation networks, design of bulk earthworks and reservoir platforms, as well as design of roadworks and parkings. This presentation will be on the design of our bulk pipelines in domestic reticulation. This falls under the design phase of the project life cycle. As we can see here, we have a general layout of our phase 5.1 gravity bulk pipeline, which falls in the Mandlakazi Regional Water Supply Scheme. We can see that we have an existing reservoir H, which is supplying water downstream to reservoir B through a 350 diameter ductile iron pipeline. From there, reservoir B supplying race C1 and D1 through a 100 and a 250 ductile iron pipeline. So before we design our pipeline, we develop design criteria through a phased approach. With this, we ensure that the bulk infrastructure is aligned with the anticipated development of the reticulation infrastructure, the growth in population, and increase in water demand. The sizing of the pipelines is viewed in the long term due to the lifespan of the pipelines, the initial lower pipeline velocities, which aids in the longevity of the pipeline and improve the overall system hydraulics, as well as the relatively low ratio of material costs to pipeline installation costs. So with our design criteria, the design criteria that we use and level service are in accordance with our client standards and requirements, which is the Zululand District Municipality. So with our bulk pipelines, we designed for a high level of service and also for a 30-year design life. We designed for supply flow rates of an average annual daily demand. This can range from 60 liters per capita per day to 100 liters per capita per day, and this depends on your areas. We also apply losses of 30%, 25% for reticulation, and 5% for bulks. We also apply a seasonal peak factor of 1.2. And for your domestic reticulation, we designed for levels of service for yard connections with a design life of 30 years and above. Similar supply flow rates, annual average daily demand between 60 to 100 liters per capita per day, with losses of 30% and an instantaneous peak of 4.5. The velocities of the pipelines are generally limited to 1 meters per second in our reticulations to 1.2 for our bulks at projected ultimate demand. So apply a 1% for growth for 30-year design life, which is linked to our Stats SA 2011. How we calculate our water demand is basically you take your population, multiply that by your supply flow rates, including your losses and your peak factor. The 20 by 60 by 60 is just converting from cubic meters per second to liters per second. So when coming to a pipeline design for bulk pipelines and domestic reticulation, we designed this in 2 stages, namely preliminary design and detailed design. With the preliminary design, the stage is developed through desktop and localized site investigations, where we determine the pressure zone or zones that needs to be designed, positioning of our reservoirs, mainly for reticulation, conducting a house count to determine the design population, determining the water demand and reservoir size using the design population obtained from the house count. Cadastral, servitude, and watercourse research, together with the aerial photography and DTM contours, provide us with sufficient data to define various route selections, which leads to the initial pipe sizing and financial models to prepare business plans and technical reports. Once at detailed design stage, all bulk pipeline routes are walked and surveyed. Yes, we go out with a survey on site and we literally walk the routes, come across snakes and all these scary things that you may find in the bush. We also, considerations for final route selections for bulk and reticulation is based upon the pipe length and hydraulics, but subject to topography, geotechnical, environmental, and social factors. For bulk pipe sizing, the bulk pipe sizing is determined through hydraulic modeling for ultimate water demands per reservoir zone, using the Hazen-Williams hydraulic head loss with due consideration for minor losses through valves and bends, and for the frictional coefficient for an older worn pipelining. We aim to achieve the desired ultimate flow rates with sufficient residual gravity aid. Long sections are then generated using PipeMaker from the final design route topographical survey, from which pipe depths and valves positions are finalized. The long sections aid in the positioning of sleeves for row crossings, for developing stream cross sections, and for identifying steep grades requiring environmental slope protection. Graphical representation of the hydraulic grade line is also carried out to ensure that at no point is low or negative pressure an issue. So this is a typical example of a long section that we pull from PipeMaker. The 2 lines that we see here, the blue and the magenta, indicating our dynamic head and static head. So your dynamic head being in blue is basically the sum of head losses in the pipelines, your valves, fittings, bends, etc. And your static head basically being the height that water has to travel as it moves through your discharge pipe. And then we have our test pressure at the top there, which normally is 25%, adding 25% to your class of your pipeline. When sizing our reticulation pipes, we use the Colebrook-White's flow nomogram and the water demand calculated. So this is the flow nomogram, which is based on Colebrook's formula using a K factor of 0.007 millimeters. So a typical example is if we had to use a 50 millimeter diameter pipe, supplying roughly 9 or 10 households based on your water demand, we would have a quantity or a quantity of 0.4 liters per second. That will be a flow. We will run it at 0.3 meters per second and have losses of 0.3. So we try by all means to keep the velocities low and the head losses low due to friction in the pipeline. And when sizing our pipes, we make sure that we do not exceed a velocity of 1 meters per second and the head loss of 1 meters per 100 meters in your pipeline. The pipe material we use for medium to large pipe diameters are OPU or OPVC class 12s and small diameters HDPE with a pressure rating to a maximum of 16 bar. For air valve and scour valve positioning, for bulk pipelines and reticulation air valves, are positioned at high points in the system to expel air out of the system. The air valves are also dual acting and let air in the system to avoid pipe collapse and reduce surge. Our valves are also positioned at low points in the system to drain out water for maintenance purposes and removing any unwanted residue or objects which may be in the pipelines, like your silts and your grit. Onto our hydraulic modeling. Using the hydraulic pipe network modeling software, WADISO, the entire system can be modeled as one, which also takes into account multiple simultaneous water demands using the Hardy-Cross iterative method. So with Hardy-Cross, the method is for determining the flow in pipe network systems where inputs and outputs are known, but the flow inside the network is unknown. Sorry, where the inputs and outputs are known, but the flow inside the network is unknown. We control pressure in the system by maintaining pressures between 1.5 bar to 6 bar at standpipes and up to a maximum of 9 bar within the system. Brake pressure tanks, pressure reducing valves, scour valves, air valves are placed in the network to control pressure in the system. We also place isolating zonal meters at off-takes for isolating and controlling water bands. This is a screenshot taken from our DSO software that we use to model our networks. This basically tells you about the pressures at your standpipes and the velocities within your pipelines. What one person needs to take into account is that these softwares are also are man-made, so you can't really rely on your software. So you need to take due diligence and make sure that whatever you spit in there, it spits out correct information. So thank you so much. One more thing, once we're done with our hydraulic design, we then prepare drawings, work out quantities that we take forward to our bill of quantities, and then the tender process starts. And I will hand over to Mr. Ngobo, who will be presenting the next presentation. Thank you so much.
Good evening, everyone. Apologies, I might sound like I fast-forwarded WhatsApp voice note. So in that case, I will not introduce myself. I've been introduced. I'll just jump straight to the next stage of the project lifecycle. As my colleague Faith had stated, that once the detailed design is completed, we then begin with the tender stage, where we compile the tender document, compiling the BOQ, your contract data specification, and just so you note, the form of contract is GCC. We then go through the bid spec review, which is basically sitting down with the clients and going through the document and just ensuring that we compliant to the government regulations and the client's internal policy. And then once the document passes the pitch spec review, it's then the project is then advertised by the client. And from there, we move on to the tender briefing, where we invite all the bidders and we basically give a clarification meeting or an explanation of the entire contract. And we are accompanied by the health and safety agent, your ECO, and your ISD. The health and safety agent and ECO basically enlightens everyone about the health and safety requirements for the project and environmental requirements for the project. And the ISD will then just cover or enlighten everyone about the social dynamics within the project footprint. And we as the consultants basically just cover the technical side of things. From there, we then take the guys through for our site visits. During COVID, we had restrictions, as we all know, and we aided the contractors by just flying or taking a drone footage of the project footprint, and that aided them in assessing their assessing the site conditions. From there, we move on to tender closing and tender opening, where the bidders will obviously bring in or submit their price tender documents. The offers are read out loud in public, and if there's any alternative offers, they have to be read right then and there. And basically, a day or two after the tender opening, we then commence with the evaluation process, where we sit down with the client and we go through the documents and we check for completeness of the document. We go through the eligibility, we go through functionality, and for the qualifying bidders, we then do a full technical evaluation report, which we then submit to the client. And once the client has really identified a potential bidder, they then put out an intention to award. And if there are no appeals within 14 days, the client then awards the contract. And we then basically move on to implementation. There's a whole lot of things that take place during implementation, and just because of time, I just decided to just pick these three, which is basically your inception, quality control, challenges, and mitigation measures. During the inception process, we basically introduce the team, we do introductions, we verify the key personnel, because contractors often submit very good CVs for the purpose of tendering. And then when it comes to the actual site work, they bring people who are less qualified or less experienced. So we just go through all those checks, and we then basically hand over the sites from the client to the contractor. We then also issue drawings and documentation. And from then we request the contractor to submit the commencement documentation, which has to be submitted within 40 days as per GCC. And that's basically your guarantees, your insurances, your construction program, your cash flows, so your safety file, and basically it's also method statement and some quality assurance documents, which we'll touch on shortly. And then during this process, we also fortunate, I think Justin had already touched on it. We managed to secure a licensed borrow pit for ZDM, and for bedding and blankets material, all contractors then source the material from the borrow pits, as you can see in the pictures. Sorry, I want to use that. Moving on to quality control, the most important things, the most important thing to understand is that the contractor is responsible for quality control, and you as the employer's agent, you are responsible for the quality assurance. And having that said, it's important to understand that teamwork is key in this industry. And in order to hand over successful projects to the client, we've got to work as a team. There's no us and them. It's very important to work as a team. There's a whole lot of other quality control measures that are in place, such as vendor approval processes, method statements for key site activities, shop drawings that have to be submitted, and that's basically your special fittings such as your strainers. They vary in length, so that's why before they can even manufacture or construct the chambers, they need to submit these shop drawings just to check that all the fittings are going to fit in the chamber. We then also have or get a third-party inspectorate who's basically responsible for quality assurance, third-party quality assurance, basically just assessing or inspecting special fittings and fabricated steel fittings at the factory. And the one more thing to note is that for various quality control and assurance processes, there's obviously different methods and systems in place for different structures and different part materials. Jumping over to challenges and mitigation measures. This is the intermediate pump station, which Justin displayed earlier on. It's one of the first projects that I've worked on when I joined, when I started working at Mandagazi. I was ER back then. For some of the challenges that we faced in this project is the fact that it was a very remote site. The access to the intermediate pump station is very steep, as Justin mentioned. We've got a slope of like 30% steep. That's a grade, and basically the intermediate pump station gets water from the Mandagazi water treatment plant, and then it pumps water up the hill through to the command reservoir, and there's a 20-bar head between the intermediate pump station and your command reservoir. So it was a very small site, and the tricky part was the fact that there's existing services. It was an existing plant pump station, which was pumping like 1 meg a day when we arrived, and we had to upgrade it to a 10 meg a day. And basically we had to construct the new intermediate pump station while the old pump station was running. And one other challenge that we had was obviously due to the difficult access to the site. As you can see, the roof slab that's the pump station roof slab that the guys are working on, we had to actually batch all the concrete on site because the ready mix concrete trucks couldn't make it through to the site. We then experienced more challenges when we had to build a new reservoir, and when we were excavating for the new reservoir foundation, we encountered rock. There was a huge rock platform that ran from where my arrow is at the bottom here, and it went all the way through underneath the existing reservoir, as you can see on your bottom left. We then tried to take out the rock using a woodpecker, which then we failed. We then realized that we had to opt for blasting, conventional blasting, but also there was a high risk of compromising the structural integrity of this existing reservoir. So we ended up opting for what we call chemical blasting. And if you look at the picture at the bottom left, that's actually the end results after chemical blasting. So the guys just drilled and applied the chemicals on the rock, and after a couple of days, it just cracks, and we managed to reach the required foundation level for the reservoir. One other challenge that we had, obviously, was the fact that the existing rising main from the existing pump station through to the waterworks, through to the command reservoir, is a ductile iron steel pipe. We had to then disconnect the old pump station and connect the new rising main pump station, and by means of connecting a flange steel, as you can see there, to ductile iron, and unfortunately you cannot weld ductile iron, so we had to just connect the two by means of a VJ coupling. Because of the fact that we had to just try and avoid the two pipes separating, we then had a thrust block. If you look at the bottom at the bottom of the top picture, there's a thrust block there that has been placed in tension, And this was so that we could then construct the permanent dust block on the opposite side, which was going to be in compression. And we wanted to just also give it enough time to cure. So as I said, it was a very difficult site, but through diligence and hard work, and obviously working as a team, we managed to successfully build this pump station. Moving over to another project that I did in Mandlakazi, we had to lay a pipe across the Mpupusi River, and as you can see in the pictures, we've got our bulk pipeline. It's a Clemron line that's running through the river. We first encountered our first challenge when we had to try and dig and reach the river bedrock, and unfortunately it was deeper than what the geotech report had stated. So that was the first challenge, and the other unfortunate part is that the contractor then missed the right season. And as you can see, the contractor was meant to lay this section in winter, but unfortunately they ended up laying it in spring. And this is why we ended up having an excavator working as a submarine, as you can see in the picture. So, but yeah, it was a very nice project. We ended up having 2 big pumps, which were constantly just pumping water out 24/7, working hard. And it was a difficult project, but we managed to successfully encase the pipe, and we managed to put in the dowels, as you can see on the middle picture here. And then, moving over to the last stage of the project, which is basically the closeout stage. This is where we then start with the commissioning, where we disinfection of the pipe and basically the entire system, the reservoirs, your pipe. There's hydraulic pressure testing. There's water tightness test on your reservoirs. And then we basically commission the entire system. And once the system is commissioned, and the contractor is ready for a practical completion inspection, we then conduct an inspection. And basically, for him to get practical completion, the site needs to be fit for purpose, fit for intended purpose. It has to be safe and secure, and it means it's operational, and basically the client can take over and operate it. So if it is operational, safe and secure, and it's doing what it's intended to do, it's the contractor then gets practical completion. And after that, we then develop a snag list for final completion. And when he's ready for final completion, he then calls for a final inspection, of which we conduct with him and the client present. And if he achieves completion, he then basically gets his half of his retention released, and then we get into the defects liability period. But at the completion inspection, he's got to have a couple of completion documentation that I've listed on the slide, which is your signed quality control file, your test results, your cube results, your site measurements sheets, your site diary, claim records, meeting minutes, as-built data, your O&M manuals. And if he's got all this information up to date, then we issue him with a completion certificate. And then we go straight into the defects liability period, which goes on for a year. And before the defects liability period ends, we are called out for an inspection. We conduct a final inspection. And if the system is still operational, there are no problems, we then give him final handover and completion. And we then do a closeout report. That's it. Thank you very much, ladies and gentlemen. Karabo, that concludes our presentation. Over to you for questions and answers. Thank you.
Karabo has had to catch a taxi because he's away in Johannesburg, not at his home, and he's there without a car. So it's Tom here from the SAICE Academy. I will deal with all the questions. Let me deal with those that have already been in the chat, and I will leave it for the three of you to bun fight who's going to answer which question. So here goes. The first question came on quite early in the session, I think when Faith was presenting. The question was, let me just find it, sorry, apologies, is a V of 1 meter per second not too low? I'm assuming your velocity you made reference to. Not sure, Justin or Faith or who's going to answer that.
Yeah, look, I'm happy to answer that. Look, I think it depends on the specific scenario. I mean, there's nothing wrong with running a pipe at up to 2, even 3 meters a second in certain situations. But obviously, if dynamic is a problem, you know, if you've got a very short line where your biggest factor is your static head, and dynamic isn't such a big issue, then yeah, by all means you can run it faster. But yeah, I think Faith was probably referring primarily with the reticulation designs, and where you designing that pipe with a instantaneous peak factor of maybe 4.5, and people are all drawing water at the same time, then I think it is key to try and keep those velocities low. And obviously the other situation is in a sort of a suction side of a pump situation, then you definitely don't want to have velocities anywhere close to 1 meter a second. Otherwise, you're going to be ending up with vacuum pressure and the like. Does that answer the question?
I'm sure if it doesn't, Justin, they will type another one in the chat. The next question is from David. He asks, was generation of electricity, in other words, hydropower, on the gravity pipelines considered? I think it's linked to the grades that you indicated, Justin, or Faith, on the pipelines.
Yeah, look, in this particular project, just the topography that we had, so you've got a treatment works that sits just below this sort of hillside where we have to pump up. So obviously that pumping system, you're not going to do any hydro on a pumping system. But the gravity system, unfortunately, from that high point, which is sitting at around about 702 meters, we've got to get water very far down the line, and your final residual heads are not sufficient. In fact, you end up having to pump again to get water to the southern parts of the project. So there's no obvious sort of additional head that you've got to work with in order to potentially generate hydropower with, unfortunately. But yeah, it's certainly something I think in the top of our minds on all water projects, if there is that option to where you've got additional head to work with, but just not on this particular contract.
Okay, thank you, Justin. The next question is from Nande. It is, what is the disadvantage of saddle fittings on a pipeline?
Yeah, look, saddle fittings, I suppose they have their place, particularly for operations where you're trying to do sort of repair situations. You get those saddle couplings that you can add onto a PVC or HDP pipeline. I think there are a few limitations on them. One possibly being, are you compromising the integrity of the pipe that you're drilling into, because you're essentially drilling into an existing pipe, and that could affect that hoop tension. And are you able to get a full bore, like if you're trying to get a full bore T, you can't do that with a saddle. You could possibly have smaller reducer Ts, reducer saddles that could work sufficiently well. So I'd say yes, they definitely have a place. We don't typically design for them on a new project, but I think they're very useful for operations. Hopefully that answers the question.
Okay, I think the question was, what is the disadvantage of the saddle? So you've indicated that they can be used, and in particular under certain circumstances, but if somebody designs it and you're the implementing agency or supervising implementation, what are the potential pitfalls of using saddles?
Yeah, Tom, I think the key thing is that you're having to drill into a pipe and potentially damaging the integrity of the hoop tension of that pipe. Whereas a T, you're not having to do a normal equal T or reducing T, you're not having to do that. I think that's probably the main issue I can think of offhand.
Okay. The next question is from Charles in Pretoria. The question is, hi, Tom. Oops, the question's just disappeared when I'm reading because another question's popped up. Sorry about that. Hi, Tom. Is the snag list for practical completion or, and then a question mark, and then a follow-up to that, and what follows after that up until the closeout report?
Sorry, can you just repeat that question, Tom?
Okay, the question is the snag list, and I think it was reference to Sizwe said something about a snag list for the practical completion, or what is it for? And then what follows after that? In other words, after the snag list up until the closeout report. In other words, I think he's trying to get sort of a time frame or a sequence of events in the project until you've issued a closeout report, assuming by then the snags will have all been dealt with.
Right. No, thank you, Tom. You can just call me Tula. They all call me Tula. Thank you for that. Basically, according to GCC, it's to the practical completion. We actually develop it before the practical completion. It's to actually assist the contractor in achieving practical completion, and then it's basically further developed for completion as well. So yeah, after the snag list, it's obviously completion, and then from completion we will then go through to your defects liability period. And during that, as I stated, during the defects liability period, we basically wait and conduct an inspection just before that defects liability period lapses. And if the works or the project is still operational and everything is still intact, the contractor then can achieve like final completion and handover, and that's where we basically release his second half of retention and we do a closeout report.
Okay, thanks, Tula. And then the next question is from Adrian. He asked, was labor-intensive construction methods for certain portions of work allowed for in the contract?
Adrian, yeah, look, it is an EPWP-based contract, so where the scope of work or the specific tasks allow for labour-based work, we certainly try to promote that. We don't, it's not advertised or put out as a labour-based contract, however, but there are targets that we have to try to achieve in terms of labour employment. It does get difficult in certain areas of this particular project because there is a lot of rock, but certainly where there isn't, and certainly in terms of the smaller diameter pipelines, a lot of the work is done on a labour-based basis. Thanks.
Okay, the next is a observation, but also a question, I guess, and that's from I think the pronunciation is Luvimbi. And that is 1.5 meters per second is actually the maximum velocity for water reticulation for safety purposes. Is that correct? Because I think, Justin, you mentioned anything up to 3. So he's just checking that maybe the 3 is under different circumstances than perhaps what was, you know, I'm not sure if you can clarify.
Yeah, look, I'm not too sure if he's which set of rules or sort of this is based on the Red Book, but certainly yes, in a small diameter reticulation type network, I would agree that in fact we wouldn't design even up to 1 meter a second. Where I was talking about 3 meters a second, and it's not something that we target or aim for, but it's certainly possible, is more on a bulk a pipeline system that one could, you know, and it all depends on the specific scenario, whether you've got a gravity line with excess head that you're able to break that pressure, then you could run the pipe at even faster than that. It's just not ideal for many other reasons, particularly the friction losses, possibly even in a raw water line damage to your lining on the pipe, and it can create other problems that are associated with it. But yes, if you are designing a reticulation project, I would target below 1 meter a second. I can't really refer to any particular rules, but rather just rule of thumb.
The Red Book states 0.6 minimum and a maximum of 1.2 meters per second in the pipelines.
There we go.
Yes. So, yeah.
Thanks, Faith.
So Justin's using old age and rule of thumb like I would do, and Faith is going back to the Red Book. So you can blame somebody else, eh, Faith?
Hey, it got me this far.
Yeah, true. We've all been there, Justin. Okay, the next question is from Noah. He asks, during the design phase, is the operational and maintenance accommodated or catered for in specific terms with regards to equipment and pumps? Should there be breakages, and are they then therefore available in a local market? I think it's your local procurement approach to this particular project and replacement of under the maintenance cycle of the project.
Yeah, I think that's a very good question. I think fairly early on in the design stage, we spoke very much in terms of the designers that we're running with it, but it's a very interactive process. Depending on the resources of the client, we interact and we have design review meetings from a very early stage. And so certainly when it comes to their preferences, in terms of pipe materials, in terms of electrical and mechanical equipment, yes, we engage the operations departments during the design review processes, and right through up to procuring the material, possibly even at construction stage, where we are having to confirm product approvals and look at data sheets. We engage with the client at that stage. It's a valid point, and we definitely do that.
And then maybe, Justin, just because it's something SAICE is pushing, because of the magnitude of this project, you spoke about billions, if I remember hearing you correctly. I'm not sure if it's this phase or what the total cost will be. Was a PPP approach not considered? So, public-private partnership to fund it, build it, design it, and then maintain and run it.
Tom, no, look, I think the project's simply evolved. Possibly had it been initially designed on this basis as such a large regional scheme, not to say that it's necessarily a massive footprint or larger than others around it, but I think the recent extension of it into cross-border, into Tlabisa, has required a relook at a lot of what we call the upstream belts, where we're now having to put in 30 kilometers of large diameter mains and abstraction and water treatment, and that's then affected a lot of the further infrastructure growth. But it's been an organic process. It hasn't it certainly wasn't designed all up front, and I think because of that, it's simply being implemented through the RBIG program. And I think what's possibly grown its stature is the interest from the minister. We've had inspections and visits from the Minister of Water Affairs and the DDG and the like, and I think that's just raised the status. They've obviously got the funding capacity, otherwise we wouldn't be in this position. So grateful to them.
And so, Justin, you doing, I think what you said is part 5, was it? Your when you showed your color Google image. What section
Correct.
are you doing?
Yeah, correct.
Okay.
Phase 5.
And that section that is cross-border, is that now going to happen, or is that a planning stage?
It's been approved in terms of the feasibility study. It's very likely to happen, but I can't really comment on on the viability of the next sort of approval processes.
And would that go back out to open tender again, or would that be an extension of the current project? I know which you'd prefer, but I'm just asking which is likely.
Am I able to say no comment at this point in time?
You can plead the fifth if that's the safest thing to do, because it's a good possibility that your client may see the presentation. So by all means, plead the fifth. No comment is good enough. Okay, let's go to the questions then. Charles asks, what skills and courses are sought after for someone working at hydropower stations? Not sure that's right within the ambit of yours, but I don't know if you've done any hydro works.
Yeah, I'm probably the last person to answer that question, but I would certainly imagine anyone that's got the skills to do that has got a really broad range of possibly, hydraulic as well as mechanical and electrical understanding. I think in this country it's still a very small aspect of our power generation, so they're probably few and far between. But good luck and kudos to him if he can get into that market.
Okay, then okay, now they're starting to get into I'm needing a job, but I'll ask it in any case, and this is particularly from a mentoring perspective. I'm assuming mentoring towards professional registration. So one of the attendees has asked if any of the presenters, and that would include you, Justin, are in the position to where you could assist with mentoring in their own workspaces. It's I know you've got nothing else to do, so it's a fair question.
Tom, I think the best thing I can do is palm that question on to you. I'm sure you in that field.
Well, yeah. We've got Marcelo Kani now, which is exactly designed for what he's asking. So let me take that question. Drop me an email, and I'll share information for you on Marcelo Kani that was launched from London, South Africa House on the 29th of March. We think it's a deal breaker. It's going to hopefully get the 110,000 people out there working in the engineering space, not only civil, mechanical, electricals, industrials, chemicals, mining, the whole catastrophe, to get to comply with the identification of engineering works. The good news is that the IDOEW regulation, which is technically going to be legal from the 25th of March 2024, is now likely to be delayed by 12 months because EXA themselves have realized they just don't have the capacity, the means, the resources, and possibly the willpower to deal with 120,000 non-registered professionals to get them registered. So drop me an email and I can certainly share it. The idea is to get funding via the SAICE and or donors, so that an individual whose company is possibly a little small company, and MSW is not tiny, but it is also a small company, doesn't have to try and find resources to pay for mentoring. The idea of Marcelo Kani is the mentors will be outside of your organization, and the cost, it's mostly driven by technology. So it allows you to do all your reporting and everything so that you click buttons and the SETA gets the monthly report to take away the administration hassles that accompanies a SETA grant. But not only that, it allows the candidate to actually build their TERs and TORs and project report all within the space of the technology. So very, very powerful tool. I'm currently talking to the EW SETA, which is your guys' game. That's energy, water, and waste treatment grouping. They are looking to fund it. And we're also talking to Sanrail on the roadside, who are looking to use money already allocated to tenders for skills development as a potential means. So if there's companies in the room, you can get through the skills development fund if you are patient and have the determination, 100K per annum for a category C candidate. And we can run a Marcelo Kani program for 42,000 per annum, all inclusive. So it's a hell of a lot cheaper than the amount of money the SETA makes available. You can get 2.5 people mentored for the same amount of money. So, but by all means, I've put my email in the chat a few times now. Drop me an email and I will help. Okay, let's come back to the question since I'm giving you a free pass here, Justin. Noah would like to know, operational and maintenance manuals. He did not hear of being answered. We're currently experiencing an aging infrastructure, which another reason has been that during the design stage, the O&M plan was not considered. So I think it's both an observation and maybe your team would like to comment, Justin.
Sorry, we're just reading the question. Just give me a moment.
Okay. I think he's saying that you spoke about project life cycle. You handled planning, Faith handled design, Tula handled implementation, but obviously the rest of the cycle is the maintenance of the asset after it has been completed. And I think his question is included in the design, and you've answered part of it by explaining that you thought carefully about what product and life cycle of the product and where there are potential breakdowns, replacement of either components or elements of the project at an early stage. So this is sort of linking onto that. He's asking whether the operation and maintenance of the system was considered in the design phase to make the asset owner, which I'm assuming is the Department of Water Affairs or that local authority, to be in a position to ensure that all that effort you put in, time and money, is going to ensure that the potable water still gets delivered as expected over the life cycle of the project.
Yeah, thanks, Noah. Thanks, Tom. It's a very good question. I think in this country, and particularly on municipal water projects where they're rural water supply projects with free basic water, you're not getting the full cycle in terms of money coming back into the coffers. There are fixed tariffs that they are looking at employing, but at this point in time, these projects, after completion, the money trickle, taps dry up, and they really rely on what is effectively the equitable share that they get from Treasury to help maintain those systems. So it is firstly very important that design specifications are of a high standard and quality to ensure that you get the design life out of the product. Obviously at the design or at the planning stage in our planning documentation and our feasibility studies, we do calculate operational costs and advise the client or Water Affairs of those costs up front so that they can try and plan and target to have the resources. It's not just materials, it's people. They have to have foot soldiers out there that can go out and manage the operations and maintenance of those projects. And I think I have seen improvements in that over the years. So where that money is coming from, I'm not entirely sure, but there is a gap because free basic water can't be free basic water, obviously, forever. You've got to get money back into the system to cover those costs. You wanted to add something? Thanks.
Sorry, is one of your team going to say something, Justin, or can we give you the next question?
No, we can move on. Thank you.
Okay, so Tulani has made a comment and then has a question. He says, interesting project. And for those that don't know, Tulani is SAICE's Grower Graduate Champion. So he's very interested in a lot of the conversation and helping all of you to get to your professional status. So he's intricately involved in Masulukani. But Tulani says, interesting project. What's the design life for the pipeline network? That's the question. And then he says, since we've seen unexpected floods in KZN ripping out water main pipelines, feeding large communities and leaving people without basic needs like water. In other words, natural disasters, do you anticipate that your pipeline, we saw the excavator sitting in the drink there when Tula was presenting, but perhaps you can comment on the project life, the design life of the pipeline.
Thanks, Tulani. I know Faith did cover that. The bulk and reticulation is designed with a view of 30 years design life. It's obviously very dependent on the pipe material, and certainly for the bulks, which are typically either steel or ductile iron. We can expect a lot longer life out of those. We've got cathodic protection systems that are sacrificial, so they don't require constant maintenance. That should ensure a design life, well over 50 years if otherwise maintained. They have, a primary, tertiary, and secondary and tertiary corrosion protection. So in terms of the bulks, we're quite comfortable that they would easily meet that 30 years and probably 50 plus. In terms of the smaller diameter, when you're getting down to your reticulation networks, those are certainly prone to a shorter lifespan, just in terms of being shallower in the ground, being located in growing communities where there's possibly new roads that get built and other additional services that come up. And so, whilst the pipeline itself has certainly shown, if you're looking at HDPE, for example, it's a well-capable pipe and should easily last 30 years. But a lot comes down to quality control and quality assurance. So during your construction phase, that's the key phase. And it starts at the factory. So you don't just accept that you're getting an HDPE pipe. You put a quality control man or quality assurance man there, you get the test results of the pipe from its raw material to when it's finished. And then on site, you carry out all your quality assurance and tests to make sure that you are getting what you've specified at the end of the day. And I think we pride ourselves in that as MSW, but we are very early on in terms of the reticulation construction stage. And maybe just moving on to the second part of the question is obviously the flooding. Look, that particular river is, I think that was quite a rare event. Yeah. But, we stuck to it and we encased that pipe onto rock foundation to make sure it wouldn't get washed away. Mandlakazi, that particular area is not possibly as prone to those sorts of stormwater type problems that a city environment is. Your runoff coefficients and that are lower with all the vegetation, and the slopes certainly in the communities are flatter. So I don't know that that's going to be a big problem later on, but we do again encase our pipes through every crossing. We have an ECO involved, that's an environmental control officer, and she makes sure that we don't miss out on those. Tula, come in.
Just to add in there, Tulani, Justin has mentioned quality control and quality assurance during construction. I think the O&M as well is the most important component that needs to be taken into account. Once the project is obviously handed over to the clients, that will also contribute in the lifespan of the services. So it's an important aspect in this industry, and the O&M is, it's a huge problem. So that needs also to be taken into account.
Thank you.
Okay, then there's a query, and it's from, I think it's K.A. Sitoli, and that is, does the company, and in this case they're referring to MSW, offer in-service training to students in other varsities apart from DUT? And before you answer that, I should just let the audience know that Justin himself is a graduate of the old Technikon Natal, probably DRT. I can't remember, Justin, how long ago did I teach you? 25 years ago, whenever it was. As is one of the other partners who I don't think is in the session tonight, Craig Mitchell. So they're looking after their alma mater, but let Justin answer the question. I don't think you are exclusively DUT, but being based in Maritzburg, that's a much easier recruiting pool for you. And like I said, both Faith and Tula are DUT graduates and obviously started there as experiential students. But over to you, Justin.
Yeah, Tom, we're slowly learning from our mistakes, and we're now looking to higher level institutions to bring people into the organization and build our strengths. No, but on a serious note, We don't currently have a particular training process. We often get students through secondments through some of our clients, where we assist them with their furthering their education. We do have or have contributed towards BSCs through University of KZN in the past. So yeah, we're open to it, and I think it comes down really to the individual that we'd be looking at. We've got no objection to bringing people in that are studying elsewhere, but obviously we're a KZN-based company, so from a logistics point of view, it probably makes sense that we look after local first, what we see as local. Yeah, but I hope that answers your question.
CPG.
Yeah, thank you. Faith and Tula, any comments on that last response from your boss?
Faith?
No, no comments.
No comments.
I'm asking because you've gone through as experiential students and are now into the process. So, you know, you can give an opinion as a student who was recruited as an experiential and how that has happened to enhance your careers, because you're still there.
Yes, Faith.
Faith, you first.
Yes, ladies first. Yes.
Well, I'll just say that, yes, I'm very grateful that I got placed at MSW Consulting, seeing how I was in the industry, what I knew when I joined as a student to what I know now. There's a great difference. So for me, I'm originally from the Free State, so I came to KZN to study at DUT, so I got placed under the Sigma-Gwenza program. So, yeah, I don't know what else to say.
I think you've said it all. Faith.
Yeah, I think I've said enough, yeah.
There's no right and wrong answer. We're just ensuring that you have an opinion, you know. Tula?
Yeah, I think, so Faith has said it all. Yeah, I'm also grateful. I've received very good experience from MSW, and I've also really grown, and I've been offered the position of associateship, and and currently being mentored to get my professional registration, and hopefully not so long after I will be a director as well. So yeah, it's been a good experience. Thanks.
And just talking about that, where is your and Faith's time frames for your PR Tech Eng applications? Now I'm going to put you really on the spot.
I'm looking at 2025, if not 2024.
Is that because you are taking longer than you expected, or just because you haven't had your 3 years yet?
I haven't had my 3 years yet, still working on it. Lacking a bit on SAICE experience, but that will be sorted. Once that is done, then I think I should be eligible for registration.
Okay, so you are missing the outcomes relating to site-related stuff, but on your outcomes group A, the design stuff, you're pretty well covered.
Yes, that's correct.
And Tula, you seem to have only been on site. You have the opposite problem.
Yes, yes, and that's why we're swapping now. Faith is going to site.
No, they're going to send me. They're going to send me back to site.
Yeah. You're too expensive to go to site, Justin. You got to put the cheap labor out on site. No kidding. Okay, then I think again, KAC Tawley, just drop me an email and I will put you in touch with MSW, and you can correspond directly with them in terms of. I'm not sure if that's my stuff or your stuff that's popped up there, Justin. In terms of, you know, talking to MSW about potential opportunities should they arise. So I have put my email in the chat. There doesn't seem to be any more questions, Justin. I know we've got 5 minutes to go in the session, but we've done very well to drag it out by another 20 minutes. So With that, unless there are any last questions or anybody that wants to engage directly with our presenters, if you do, stick up your hand and I'll enable you to talk. If not, then we will wrap up for the night and I will close out with a little bit of SAICE subliminal marketing. There we are. Justin, you stuck your hand up.
Tom, sorry, I picked up your WhatsApp quite late on. I think we were already nearly through the presentation. So just apologies that we did rush through everything. I probably didn't realize we had more time available. You mentioned possibility of me displaying those little video clips of the transient analysis. I don't know if it's something I can try and do.
Now, if you want to try, I think it just enhances the experience, so that things you're making reference to. Just remember, the aim of these series is to make students who are sitting thinking, why the hell am I studying this, realize that it is something that they will apply if they go into the workspace, like Faith and Tula and yourself have done. I doubt any of you, when you were sitting in a classroom suffering as a student, ever thought you would apply the stuff. And I mean, Faith was rattling off all those old farts that have been long dead in their systems and methodology, which are still in use. So by all means, if you can get it up and running, no problem. We are more than happy to accommodate it. Those that would like to step out are also welcome to do so. So if you can get it up and running, Justin, go for it. If it's got sound, just remember to, in the share, enable your computer's sound when you select share screen.
All right. Can you guys see that animation?
We can, and then we see a bird every now and again, but we can see the animation. Yeah. Okay.
Look, this is just a fairly typical. It's a rising main. It's a 700 diameter rising main. A fairly low static lift. I think it's about 110 meters. And the first video clip is just going to show you a surge condition without any mitigation, but obviously air valves positioned. So you'll see as the air valves go red, they activate. Hopefully I've got the right one open here. So this is obviously in like a burst or shut valve situation. You can see where the shaded line, where it shades below the pipeline is essentially pressures are going negative. And we're getting a return wave up there at about 830 odd meters, which is, let's call it 23 bar pressure. And then remembering that this is on 110 bar static line. I think with dynamic it's around 110 if I'm not mistaken. So your head rise in terms of transient is quite significant, and this carries on for a while, back and forth, positive wave, negative wave, and it just doesn't. There's no control mechanism. There's no mitigation. I'll end that one now, and then I'll just jump to another example, if I may. All right, let me just pause that. So in this situation, we've added, I don't know, can you see my mouse?
We can, Justin. We can see your mouse that you are hovering over one of your valves.
Yeah, so there's actually a non-return valve now put in this location. You'll see a spike on the return wave. And by doing that, you're limiting the effect of that transit coming back to your pump station. So you can see now the return wave only gets up to around about 720, 730 meters, where it was 830. So you've now reduced that additional head by in the order of 10 bar. And it quite quickly settles down as well. Okay. And then I'll just show one further example. Now this is an example with adding a large flywheel onto your pumps, which essentially just reduces that inertia on the pump. And it just calms the whole system down.
What you're showing here, Justin, is just different tools, engineering tools, to manage different circumstances within a network.
Correct. Yeah. Now these are surge mitigation measures, if you want to call it. But yeah, they are simple mechanical or hydraulic means to try and minimize that water hammer. I'm by no means an expert on this. This was done by a colleague of mine, but it's just quite fascinating to see.
Yeah.
It's a bit of a dark art, but yeah, it is interesting. Now you can see in this situation, there's no negative pressure. That grey area is well above the pipeline level, so you've got nothing going negative. Yeah, I think that concludes it, guys. I hope that was interesting.
Well, Justin, Faith and Tula, thank you very much again for your time. We do really appreciate it, and for sharing not only the project, but your collective knowledge. It is greatly appreciated by SAICE SAS, which is Karabo's Growing Forward initiative, and obviously from my side, from the Academy. Thank you to all our delegates who've attended, both students and all members of the profession. I've seen lots of names that are familiar that are by no means still students, probably themselves thinking like you guys are. They're glad they're not a student any longer. But we thank you for your attendance and support of the webinar.